Section 2, Unit 3, Semi-Precision Measurement. Introduction. Tools for measuring distances, angles, and other dimensions. Specified print sizes. Dimensions on prints have tolerances, amounts of allowable variation. Semi-precision measurement. What is semi-precision measurement? Measurement where tolerances, levels of desired accuracy are within 1/64th or 1/100th of an inch, 0.5 millimeters, or 1 degree. Always treat measuring instruments with care. Flat tools with graduations used to measure linear straight lines distances. English rules usually divide inches into 1/8, 1/16, 1/32, and 1/64th. Decimal rules divide 1/10, 1/50th, and 1/100th of an inch. Metric rules graduate to millimeter and half millimeter divisions. A hook rule makes it easier to measure from an edge. Small rules can be useful in tight spaces. Rules being used to measure linear distances. So you can see that if you count these, that's 8/16, or 1/2. And then this one's a little bit harder to see, but by holding the edge of the rule against the surface being measured, the graduations are more easily read than when a rule is lying flat. So you can see it's directly touching here versus you got a gap, so you're more likely to misconstrue the. Aligning a major graduation with an edge is easier than B, aligning the end of a rule. In this example, the actual measurement would be 1 inch less than the reading, since the 1 inch graduation is aligned on the edge of the part. So it's just saying it's easier to put the 1 inch line on there than to guess at putting the edge over it. Some sample measurements using 1/8 and 1/16 graduations and B 1/32 and 1/64 graduations. Notice the quick reading graduations. Remember to always reduce the fractional readings to the lowest terms. So it's just showing you different lines of some sample metric rule measurements. So 1 1/2. So you got 1, 2, 3 halves. So that's 1 1/2. Have 2 legs that contract parts to measure them. Slide calipers and similar to rules. Measure internal and or external dimensions. Outside calipers measure external dimensions. Inside calipers measure internal dimensions. Transfer or Helder type tools must transfer to measure with a rule. A slide caliper can be used to take internal and external measurements. Notice that a different reference line is used for internal and external dimensions. So what it's saying is on this one, it can, if it's in between, it's going to be on the out. If it's on the outside of it, it's going to be on the in, which is a little backwards, I understand, but that's how they do it. An outside caliper and an inside caliper. Notice the difference in the shape of the legs. So this would be an outside caliper because you're going to be touching the outside of a part, where this one you'd be inside of a hole or something like that. Transferring the outside caliper measurement to a rule, so you'll tap that on the end of it, and wherever it lines up is where your dimension will be. Transferring an inside caliper measurement to a hook rule, so you'll tap it against the hook and then see what the measurement is. The jaws of a spring type caliper are held under tension by a spring and opened or closed by turning the adjustment screw. The firm joint caliper has no fine adjustment. The lock joint caliper can be set to an approximate size and locked in place by turning the larger finger screw clockwise. Then the smaller fine adjustment finger screw can be used to obtain the final setting. 2-piece tools can be adjusted and disassembled. The beam holds blade in place. Blades are graduated and you may have common angles on the end. Used to check for perpendicularity. Combination set consists of a blade, a square head, center head, and protractor head. An adjustable square with different blades. So it's got an angle on this one where this is a 90 degree. Using adjustable square to check a square. So just putting it on there and seeing if there's any gaps in between. There's the combination set. Making a comparative measurement of a 45-degree angle with a combination square. Hold one surface slightly or tightly against the square head and check for gaps between the blade and the second surface. Protractors measure angles. Protractors depth gauge adds a rule. Bevels compare angles. Transfer tools with no graduations. Die maker squares and hybrid square protractors. Measuring an angle with a plane protractor, the arm can be locked in place by a finger screw after positioning. The protractor depth gauge, a universal bevel, and a combination bevel. Two types of die maker squares. They can be used to check perpendicularity and angles up to 10 degrees. Tools without adjustment used to measure comparative size. Typical radius and fillet gauges, angle gauges, and screw pitch gauges. A radius and a fillet gauge set is shown here. So that's a radius set, as you can see. Uses of radius and fillet gauges. So you could use it 5 different ways. And the uses of a radius and fillet gauges. So there's the fillet gauges. And there's an example of a screw pitch gauge. So it's got different screw pitches on there. This one's between 4 and 18, 52 and 84, and 20 to 50. Checking the threads with a screw pitch gauge. So you're just going to make sure that it lines up perfectly with the thread.